A master's in management program with various schools, including Harvard Business School. During his early years, he designed highway and railroad bridges in Illinois, Michigan, Florida, and Washington, ultimately becoming registered as a civil engineer in 11 U.S. states. With over 27 years of award-winning structural design and construction experience in transportation, light and heavy rail, Mansoor has become a leading voice in the transportation industry for projects with alternate delivery. His hands-on style and detail-oriented nature have produced several award-winning plans throughout the U.S. Recently, here in the DFW Metroplex, Mansoor has had the privilege of leading the Bridgefarmer engineers in the design of 4 monumental mega projects. These include the DART Orange Line extension from Bachman Station to DFW International Airport, the DFW connector, areas 1 through 3, the LBJ managed lanes, and the Loop 12 114 Interchange, which we will be hearing about today. So please help me welcome Mansoor Ashan.
Thank you, Leslie. Thank you all for coming. It's truly an honor to be here presenting this very, very challenging and interesting project. It was a collective effort of a lot of people. Can you all hear us? Nope.
Can you lean in a little
Nope.
more?
Was the microphone turned up?
I think you just, if you can.
Is it better? Nope. Okay. While they're working on the sound system, let me continue with our presentation. As I was saying, that it's truly an honor to be here, and indeed it's a collective effort of several people who made this project happen. My firm, Bridgefarmer, was the lead engineer on this project, and we were able to work with several agencies and several of the companies who were involved in production of these set of plans. I certainly want to acknowledge them and want to thank them for their hard work, for their help, and also making Dallas a truly multimodal city now. The reason this project is so dear to me and to so many other people is because this project has put us, Dallas Metroplex, as one of the leading cities in southern United States, where you can now have a choice whether you come from downtown Dallas going to the airport at DFW, or you are going to attend a convention at the city of Irving. You can use the train, you can always use the car. The reason this is called Dallas Diamond, and this is a cheap shot of a diamond, but at any rate, what hides this is our 3 championships in this stadium, and that is indeed what makes us so special. But all kidding aside, this project is called Dallas Diamond because of the hard effort of several agencies who came together to put this extremely complex puzzle together. Whether it's TxDOT, whether it's DART, whether it's City of Irving, whether it's the Irving Flood Control District, or the NCT COG. They all worked hand in hand, and Bridgefarmer is fortunate, and my firm is fortunate in that regards, to have an opportunity to work with all of them such that we can build this extremely complex corridor where you have to deal with multiple agencies, you have to deal with multiple people who can come together. I'm glad to tell you this, that projects like this don't happen when agencies are not cooperating to one another. We have seen that across the nation in many locations where cities, counties, and alike, they don't come together for the common good of the project. What made this project so special that all of us had one single plan, and that was to build this corridor, build the light rail, build what's needed for the city of Irving, what is needed for the city of Dallas, and what's important to DART, and at the end of the day, keep TxDOT mobility menu on mind and make sure that that works. So as you can see, this thing nicely fits. And as they say, the proof is in the pudding. And now this corridor is open to the traffic. I do want to acknowledge all the partners, TxDOT, DART, COG, City of Irving, and the contractor who worked very hard, which was led by Zachary and Senecola team. When Bridgefarmer was selected for this project, we thought it would be just a four-level interchange, as most of you have done many four-level interchanges, and we were glad to have that work. But little did we know that we will be coordinating with 6 different agencies, and we will be working in a very, very tight right-of-way with a very heavy traffic in that corridor. This is the section which was completed. The one which shows up in green is the Loop 12-114 project, and the one which is in red is called Loop 12-183, with another 5-level interchange and 2 4-level interchanges being designed by Bridgefarmer at this time. Once completed, this entire complex corridor will have a Loop 12-114, which is a 4-level interchange, and then there will be 1 more 5-level interchange and 3 more 4-level interchanges, and hence the diamond. Before construction, this project had all kinds of challenges. As you can see, the picture on your left shows that the corridor is functionally obsolete, structures were structurally obsolete, and with a high traffic volume. These are some of the pictures of before this corridor started to get this facelift. Most of the structures were built in 60s and 70s, and they were dated. The lane widths were not sufficient, the capacity was not enough, and the structures were not adequate, neither structurally nor capacity-wise. So when we got involved with the project, we saw a few of these challenges which were truly unique to engineering. First and foremost was the coordination amongst the agencies. Traffic volume of about 200,000 cars. A shared right-of-way between TxDOT and DART. Poor soil. And the soil conditions over there are extremely changing and diverse. And our geotech partners at that time helped us quite a bit to come up with unique ideas how we were able to build this corridor. And then, as all of us know, that whenever you are working in the floodplain, you have issues to deal with the permits, whether it's 408, 404, or alike. And I certainly am not a permits guy, but they are never easy to get approved or get the coordinations done. This project had 19 different type of bridges, about 600,000 square foot of deck area, 33 varying different type of walls, some MSC walls, some hybrid walls, and some conventional cast-in-place walls. Then the construction of light rail, construction of the freight rail, a rail crossing over a rail, vertical clearances, catenary poles, and then to top it all, the accelerated schedule of the project. Our client, which was TxDOT, asked us to complete the job, and we could not delay the schedule and had to get all the players on board day one. For the purpose of civil engineering, as an engineer, I would like to draw your attention to these four major items, which were extremely challenging for an engineering project. This project was first of its kind to use pre-stressed, precast concrete retaining walls. At that time, it was first of its kind to use hybrid walls. At that time, it was also first of its type to use 3D modeling, as we use now quite often on all the design-build projects which Bridgefarmers is involved with. We certainly do 3D modeling for our contractors, whether we use a Terra model or whatever software contractors like to use. They ask for a 3D model, and we always provide them. And then sharing the right-of-way between TxDOT and DART. This is a picture of how the wall system was put together and how these walls came together for this corridor. This is pretty interesting for all of us. As you can see that the cut section has precast, pre-stressed panels which are between the drill shafts. And the drill shafts are about 8 to 10 foot in spacing. Our team came up with this idea that if we use pre-stressed panels, we can certainly increase the spacing between the drill shafts. It helped the constructability. It also helped the contractor to build the job faster. But as you noticed on the top of these drill shafts, there is a MSC wall, and that's in the fill section. And this is a typical section happening at one location and several times. So on the top, you notice that there is a MSC wall which is holding back the fill, and then this MSC wall is sitting on top of the drill shaft. Without a leveling pad, without any kind of other system, our structural engineers have to work very closely with our geotechnical engineers to come up with a system such that the overall stiffnesses of these members work together. And then the assumptions of the soil properties are such that they can be registered such in our programs that, and these were our internal softwares which we used for this project, such that they can be closely approximated to the situation in the field. And then as you notice that to prevent the sliding, we have a lip on the top of the drill shaft such that it could act as a shear key and engage itself when it's trying to slide itself out. These were some of the closure pores and the details of the closure pores as you noticed over here. But the big factor is that the contractor, Zachary and Sinecola, worked very closely with the designers, and they did not use this detail, and they were able to place the walls next to one another. Ordinarily, an MSC wall is an 8 inches thick panel or such. But we used about 4 to 6 inches thick panel because we were able to pre-stress them. And to me, as a bridge engineer, I will tell you, it's no different than using your PVC panels we used on decks. The pre-stressed concrete panels in the horizontal plane, in this particular case, they are applied in the vertical direction, and they are holding back the soil, and they were able to take the load. I think it's a pretty clever application for whenever there is a situation like this. I encourage you all to look into this thing for your projects, because this certainly could save several drill shafts, and we were able to save about 30% of the drill shafts on the entire corridor. This is a detail of a pre-stressed panels when they come together, and then you can see the strands are protruding out, and then on the bottom side you can see that they are being lapped together. This is the completed work, or the work in progress. As you can see on the top picture, the top portion of the wall is on the fill section, and the bottom portion of the wall is on the cut section. By providing this kind of a detail, it certainly helped contractor keep up with the schedule. Despite of all kinds of issues related at that time, this certainly was very, very helpful to have a hybrid wall, which is combination of the drill shafts, combination of the MSC walls, and transferring the loads from the MSC walls back to the drill shafts, and the drill shafts were actually taking the loads in this particular application. I believe nowadays no job is complete without having a 3D model. 3D modeling has truly changed the engineering nowadays. It helps design build projects go faster, it helps the bid build jobs go faster, and it keeps, from a consultant standpoint, it keeps the owners, whether it's TxDOT, DART, or cities, very much engaged, and things which are important to them, they get involved, they are part of the discussion, and they give directions how and where to direct the project manager or the project team, especially things which are important to them. And imagine if you have 6 different agencies with 6 different interests, you have to have something which matters to them, and a lot of times a thing which is important to TxDOT may or may not be important to DART. We believe this tool was very, very helpful. We believe this tool helped get a meaningful conversation, and it was very much engaging in terms of getting all agencies buy-out in terms of the progress of the project. As you can see, these pictures show you that if you have a drill shaft conflicting with a footing, if you have a utility conflicting with a footing, or you have utilities which are messing with your walls, you can quickly see that. And the way we did this project was that we developed this for every step of the way. We used to have a weekly progress meeting, and every week we would invite our partners, and they will see the development of the project, and they will see in 3D to see whether or not things which are important to them are truly taking care of them. So these meetings, when we invited utility folks, or when we invited DART, or we invited TxDOT, these meetings were very, very helpful to them to see and address the issues which were critical to them. One of the other challenge on this project was where this corridor was being built, the orange line I-1, I-2, and eventually now I-3, which connects to the DFW airport and had to go through the same corridor. That challenge was truly monumental because DART, rightfully so, wanted to have a quicker, faster delivery of the project, hence it was a design-build project, and TxDOT had selected a contractor with a low bid to build this corridor. From the design standpoint, we were dealing with a poor soil, we were dealing with over 200 various type of utilities in getting a different kind of a utility corridor set up. And then, to make things interesting, when we go over Loop 12, we had only 2 choices. We said, well, how do we accommodate the needs for DART, whether we go over on top of Loop 12 or whether we go under Loop 12? As you know, tunnel is not a popular thing in Dallas. If it was popular, we would be building a tunnel today on LBJ, and you know that it's going to be an open cut. So we knew that that part is not going to work. At the same time, when we looked at going over top of Loop 12 with the DART light rail, it was causing us a extremely long structure. It was causing us long straddle bends. The bridges were getting very, very long, and the cost of the project was going very, very higher than, and much, much higher than where the original budget was started. So we came up with the idea of doing a tunnel, but we called it an untunnel because the tunnel requires a 300, if you are over 300 feet long, then you need to provide the ventilation, you need to provide the life and safety, and all the requirements of the tunnel. So our designers and our team came up with an idea of, let's call it an untunnel, such that we can provide the ventilation in that area. And here's a good example of that we were able to keep one side open, and by doing so we were able to get away from the ventilation requirement. This is the light rail going under under State Highway 114, and you can see that catenary poles are on both sides, and we were not under the bridge because of the vertical clearance requirements, and we weren't able to raise the profile. How many times we see this where a rail is crossing a rail? So you have a BNSF on top of a DART light rail, and BNSF has 33 trains running on this track, very active, very busy track, and we were able to put an agreement between DART, TxDOT, BNSF, and a railroad agreement was in place such that we were able to get the project on time. The constriction and the restricted right-of-way was a challenge for both designers and for construction purposes as well. Due to the restricted right-of-way, there was no launch area, there was no construction site available for the contractor. So when the old Cowboy Stadium was imploded, this area opened up. And now this area is being used for the construction of beams, and you might see it driving by that there are a lot of beams being fabricated, and this area has become available for a launching pad. This project is also one of the first ones with a barrier separated concurrent managed lanes, and you can see this being constructed here. The current station, which is the University of Dallas station, it is in the floodplain, and we were able to redirect the flow to mitigate the University of Dallas station. It was a challenge for the entire team, and City of Irving Flood Control, and the entire team worked very hard to come up with a solution such that we can provide a station where DART desired and where we can have a station so that the students can easily go back to the campus. And this is perhaps a good shot of a completed picture of University of Dallas Station. Once the project is completed, look at the length of the drill shafts and length of the straddle bends, which are over 100 feet at some locations. And this particular picture is very interesting from bridge structures and the structural engineer's standpoint. You can see a straddle bend, and you can see where the beams are resting right in the center of the straddle bend. Usually straddle bends have a load carry at one location or the other, so it was the worst possible place where the load could be coming in. And on the far side, you can see, if you are driving by, and as all of us who are civil engineers, and myself included, nerd by nature, so I look at the walls and I say, well, okay, so there is an MSE wall, there is a cast-in-place wall, I can see a drill shaft wall, and I can see something else is going on. And that's exactly what this job is. There is something else going on. So it has all kinds of challenges. Now once you drive by, you can see that there are different kinds of walls doing their purpose for which they were designed for. Once this job and this project is completed, it has put us, Dallas Metroplex, as the poster for the southern United States to build the very first multimodal corridor where you can fly into DFW Airport, you have a choice of renting a car, or you can take a train. You can take a train and attend a conference in City of Irving, you can go downtown Dallas, and you can take the train back and fly out of it. It is no different than what you would do in Chicago or in Boston or any other modern city. And we are glad that Bridgefarmer was part of it. This is a completed picture of the project. Now, since the project has been completed, it was opened not too long ago. It's the first of its type where TxDOT and DART share the common right-of-way. Usually when the contractors have to work within the same right-of-way, as when this project was going on, Zachary and Cinecola's contract was with DART, and KSWRP was working as a design builder for DART. So it was difficult for both of them to coordinate that what were the needs of TxDOT, what were the needs of DART, who is in what part of the right-of-way, and when do they share. But our leadership, I will tell you, the local leadership in Metroplex are serious about solving the problems of mobility, and they were able to come up with a solution and work together and make the contractors work in a singular form such that they were able to deliver the corridor as promised on time. This project has also improved the student ridership. It has improved the number of students attending University of Dallas, and it has given people choices now that you can take the train to the campus, to the school, and has increased the enrollment in colleges. The project was completed in March of 2013, and citizens of Dallas were promised this corridor, citizens of Irving were promised this corridor, and the project met the schedule. Because of its uniqueness, the engineering challenges, its coordination, its construction, and it's the farsightedness of all the leadership in this area truly got this project recognized nationwide. And it was awarded the National Gold Award, it was awarded the Local Gold Award because of engineering challenges we all deal with as engineers, as all of you deal with day in, day out at your jobs. But thinking not just for engineering standpoint, but how to solve a problem of mobility, how to solve a problem which could connect the cities, connect the modes of transportation, and certainly can make life easy for all of us. That's what this project did. Once completed the second phase of this project, this multimodal corridor would have several interchanges which will make our mobility much better once it's completed, probably end of the next year or so. With that, this was my last slide, and this is a good picture. I want you all to see that. At least I am, and Bridgefarmer team is very proud of it, that we were able to accomplish this, and we were able to work with outstanding clients who gave us all the support throughout. Thank you so much, and I'm here to answer any questions.
We got time for a couple questions if we have any.
The project was $238 million from TxDOT standpoint, and that was for Loop 12-114 highway part. And I think from DART design build, which is, I don't know how that math worked out, but that was about $400 or $450 million I-1, I-2 corridor. We have our internal software, and we have a fairly rigorous R&D program internally at Bridgefarmer, and we use that software for most of our complicated projects. So commercial softwares, which you all are familiar with, RISA or STAT or any of the TxDOT publicly available softwares, we use those. But for complicated projects, we use our internal software. Yes, sir. Well, phase one, what we call it phase one, is loop 12.114, which is completed. And phase two is in design right now, and we should be finishing up that design by the end of this year, about 90% complete, and then 100% will be probably sometimes next year. And that project also connects with the design build project, which is loop 12.1, which is 183 corridor going on right now. And then this whole thing will come together again once our piece is done, and as well as 183 design build part is done. Yes, ma'am. When this project was going on, at that time we didn't, but now we do. So at the time when this project was at full swing, we did not use cloud technology. Nowadays, I wouldn't know, man.
All right. Well, thank you very much, Mr. Ashan.
Thank you.
As part of our appreciation, we'd like to present you the ASE portfolio. Thank you very much.